In this video, I'll show you how a baby boost works. So a baby boost will increase the hold time, and it's a alternative method to increase the capacitor, because a capacitor will become really big if you increase it a lot, but a baby boost could be more compact. So the idea is that when you have a power outage, the voltage will start to drop, and when you reach the minimum voltage that you want to have, you activate the baby boost, and then the voltage will increase back to 400, for example. And it will stay there for a while until this bulk capacitor is charged out, and then will start falling again. So in the case of a power outage, this voltage source will stop supplying power, and therefore this voltage would be zero, and also this current here would be zero, so there is no power flowing from the PFC to the baby boost. So we can just actually look at this part in order to analyze the baby boost. So this is the part that I just showed you. So we have a MOSFET here, as you see. When this one is on, it would just bypass the baby boost. This would be the equivalent circuit, because when the MOSFET is on, the voltage here and here would be the same. So we will not induce any current over this inductor. But when it's off, we will just get a boost converter. But when it's off, we will just have a boost converter. So we need to add a controller to this MOSFET in order to control the gain that we want for this one to, for example, be 400, while for this one could be as low as 200 volts. So what happens when we have a power outage is that the voltage starts to drop. And when it goes down to, for example, 350, we'll open this MOSFET. So it's basically open. So we now just have a boost converter. So this baby boost would work. So the idea of the baby boost is that after the power outage, the bulk voltage here will start to drop. So it starts at 400, for example, and then it goes down to 350. And if we set 350 as the threshold voltage, we will activate the baby boost. That would mean that we open this MOSFET here, so we just have a boost converter. So the baby boost is just a hidden boost converter, and then it activates when we need it. So in order to make this boost converter power dense, the inductor here needs to be small, and as well as this capacitor. So this capacitor here and the capacitance here will also be small. So this capacitance on the bulk side could be, for example, 100 times larger than the capacitance on the baby. This capacitor here will just control the ripple, and this will control the hold-up time before we activate the baby boost. But this bulk capacitance still needs to be large, because we don't want to activate the baby boost too often. But we also want to have a lower limit on the baby boost. In this graph here, you can see that. Because if we didn't have a limit, like in this graph here, and the voltage on the bulk side, for example, went to 0 voltage, then we would have a problem when the power comes back again, because we will still have a very large gain in the baby boost.